Ibogaine is a fascinating, naturally occurring psychoactive compound, primarily found in the root bark of the Tabernanthe iboga plant, native to Central Africa. It has garnered attention for its potential therapeutic effects, particularly in the context of addiction treatment. Chemical makeup and structure. Delving into its chemical essence, ibogaine emerges as a complex indole alkaloid. Its fundamental building blocks combine to form the chemical formula C20H26N2O, resulting in a molecular weight of approximately 310.43 grams per mole. The scientific community formally recognizes it by the intricate systematic name 1R, 15R, 17S, 18S, minus 17-ethyl, minus 7-methoxy, minus 3,13-diazepentacyclo, 113.3.1.2.10.4.9.13.18.nonadica, minus 2 parentheses 10 parentheses comma 4 parentheses 9 parentheses comma 5 comma 7 comma tetraene. Beyond its formula, ibogaine is categorized as an organic heteropentacyclic compound, an aromatic ether, and specifically a monoterpenoid indole alkaloid. Intriguingly, its structure is closely related to ibogamine, differing primarily by a methoxy group strategically positioned where an indole hydrogen would typically reside. The molecule's inherent complexity is further highlighted by its several chiral centers, which dictate its precise three-dimensional arrangement, known as stereochemistry. The specific notation 1R, 15R, 17S, 18S provides a blueprint for the absolute configuration at these crucial centers. Extraction of ibogaine from plants. The journey of ibogaine from its botanical origins begins primarily in the root bark of the Tabernanthe iboga shrub. While a direct isolation method exists, it often proves to be an inefficient route, yielding only small quantities of the desired compound. Consequently, a more prevalent and often commercially viable strategy involves a semi-synthetic procedure utilizing Voacanga. This alternative alkaloid is found in much greater abundance within the root bark of Voacanga africana. The generalized extraction process unfolds in a series of careful steps. Preparation of plant material. The initial phase involves meticulously grinding the root bark, whether from Tabernanthe iboga or Voacanga africana. This crucial step significantly increases the surface area, optimizing the subsequent extraction. Acidic immersion. The finely ground material is then steeped in an aqueous acidic solution, commonly dilute hydrochloric acid, HCl. The acidic environment protonates the basic nitrogen atoms within the alkaloids, rendering them water-soluble. This allows the precious compounds to be effectively leached from the plant matrix. This process is often repeated until virtually no alkaloids remain in the plant material. Removal of solids. Following the acidic treatment, the extract undergoes filtration to meticulously separate and remove any lingering solid plant debris. Alkaline conversion. The clear, filtered aqueous extract is then transformed by the addition of a suitable base, such as concentrated ammonium hydroxide, NH4OH. This renders the solution alkaline, causing the deprotonated alkaloids to lose their water solubility and precipitate out, forming a crude solid. Isolation of crude alkaloids. The resulting brown precipitate, a mixture of crude alkaloids including ibogaine or its precursor Voacanga, is carefully separated from the liquid. This separation is typically achieved through centrifugation or filtration, followed by a drying process. For those employing the semi-synthetic pathway, the isolated Voacanga embarks on further chemical transformations. These typically involve a sequence of basic hydrolysis followed by acid decarboxylation, ultimately culminating in the formation of ibogaine. It's also worth noting that recent breakthroughs have led to the total synthesis of ibogaine from more accessible and cost-effective chemicals like pyridine, offering a promising, sustainable alternative to reliance on plant harvesting. Purification methods. Once the initial extraction yields crude ibogaine, or Voacanga for the semi-synthetic route, the critical phase of purification begins. This aims to eliminate impurities and achieve a high level of purity for the compound. While the highly specific, large-scale purification protocols are often trade secrets, several general and effective methods are commonly employed for alkaloid purification. Solvent-solvent extraction. This technique leverages the differing solubilities of ibogaine and its accompanying impurities in two immiscible solvents. By carefully adjusting the pH, ibogaine can be selectively moved between an organic layer and an aqueous layer, effectively isolating it from unwanted contaminants. Column chromatography. A cornerstone of organic chemistry purification, column chromatography provides a powerful means of separation. The crude ibogaine is introduced onto a column packed with a specialized stationary phase, for example, silica gel. As a carefully chosen solvent mixture, the mobile phase, flows through the column, the different compounds travel at varying speeds, allowing for their clean separation. Crystallization. This elegant and often final purification step relies on the principle of solubility. The crude ibogaine is dissolved in a hot solvent, and as the solution slowly cools, pure ibogaine molecules meticulously arrange themselves into a crystalline lattice, leaving impurities dissolved in the remaining liquid, the mother liquor. This process can be repeated multiple times to achieve exceptional purity. Salt formation. Ibogaine is frequently converted into its hydrochloride salt, C20H26N2O.HCl. This white solid form of ibogaine offers enhanced water solubility and improved stability compared to its free base counterpart. The controlled formation and subsequent crystallization of this salt can significantly contribute to the overall purification process. It is paramount to remember that the intricate processes of producing and handling ibogaine are subject to stringent regulations across many nations. This is a direct consequence of its potent psychoactive properties and the inherent risks associated with its use.